Welcome to The Explainer. So, we've all seen what's happened with AI, like ChatGPT, right? It just keeps getting smarter in this really predictable way. The big question in this study we're breaking down today is, can we do the exact same thing for self-driving cars? Can we make them predictably better?
Okay, so here's our game plan. We're going to start with the big idea behind AI's crazy growth. Then, we'll look at the ultimate driving test. You won't believe the amount of data. We'll uncover the rules that seem to govern these driving models and then connect it all back to the most important question. Does smarter training actually mean safer driving? Let's dive in.
All right, first things first. To really get what's going on here, we've got to connect the dots between the kind of AI everyone's talking about, large language models, and the AI that's actually behind the wheel of the self-driving car. So think about it like this. What does a language model do? It just predicts the next word in a sentence, right? Well, these driving models do something surprisingly similar. They predict the next move in a traffic scene. It's like they're treating the whole road as this giant, complex conversation where every single car, every cyclist, every person walking is constantly reacting to everyone else. It's a really powerful way to frame the problem. And this all hinges on this really powerful concept called scaling laws. Basically, it's the discovery that if you just pour more resources into an AI model, we're talking more data, more computing power, a bigger model size, its performance gets better in a really predictable way. It's pretty much the secret sauce that's fueled this whole AI explosion. But the billion-dollar question has always been, does that same magic work for something as messy and chaotic as driving?
So, the researchers at Waymo got down to business. They wanted to answer four really key questions. 1. Do these scaling laws even work for driving? 2. If they do, what's the best recipe for scaling them up? 3. And this is the big one, does getting a better test score in training actually make a safer driver? And 4. Can smaller, nimbler models ever really compete with the huge ones? Okay, so how on earth do you even start to test a theory like this? Well, you need data, and not just a little bit of data. You need an absolutely enormous amount of it. What Waymo put together for this study, it's just colossal.
Okay, so check this out. The foundation for all of this is a massive collection of real-world driving footage. They started with over 447,000 hours of human driving. I mean, just think about that. That's a mind-boggling amount of time.
And to put that in perspective, all that driving time adds up to about 5.6 million miles on the road. But here's where it gets really crazy. They took that entire treasure trove of experience and chopped it up into over 500 million, that's 541 million, unique little lessons for the AI to learn from. The scale is just staggering.
And this table really just drives home the scale of what we're talking about here. Look at these numbers. Almost 60 million segments, 373 billion agents. That's every car, person, and bike. But what's really important is where this data comes from. We're talking dense, chaotic cities, San Francisco, Phoenix, Los Angeles. So this isn't just a ton of boring highway driving. It's complex, it's diverse, and it's absolutely packed with all those weird, rare, long-tail events that are the absolute hardest for an AI to learn how to handle.
So armed with this mountain of data, the researchers started training a whole bunch of different models, big ones, small ones, and everything in between, to see if these scaling laws really do apply to predicting motion. And the answer they found? A resounding yes, it worked. Just like with language models, as you throw more computing power at the problem, the model's ability to predict what's going to happen next gets better and better. You can see it right here. The error rate just drops in this beautiful, predictable, smooth curve. And that is a huge deal. It suggests that the path to better self-driving AI might not be about waiting for some magical new algorithm, but about systematically and predictably scaling up the stuff we already have. And they didn't just find that it works, they even figured out the secret recipe for making it work best. It turns out, if you have a set amount of computing power to spend, you get the most bang for your buck by making the model's brain, its number of parameters, grow about 1.5 times faster than the dataset you're feeding it. They found the sweet spot. But here's where things get really interesting. There's a twist. Compared to language models, it turns out that driving models are just incredibly data hungry. For the exact same amount of compute, the ideal language model is about 50 times larger than the ideal driving model. So what does that mean? It means that to make a driving AI smarter, the best move isn't necessarily giving it a bigger brain. It's about feeding it vastly, vastly more real-world experience.
Okay, this all leads us to what is, without a doubt, the most important question in this entire study. It's great that these models are getting better test scores and training, but does that actually translate to a safer, more capable driver out there on the actual road? Yeah, to put it another way, does being a good student in the classroom make you a good driver on the road? Because for years, honestly, the conventional wisdom in the self-driving world was that these two things weren't really all that connected. A good training score didn't necessarily mean good real-world performance. Well, the results here are pretty remarkable. Take a look at these two graphs. The one on the left, that's the model's classroom grade. It's getting better and better at predicting what's going to happen. The graph on the right, that's its road test, how often it fails in a realistic simulation where its choices actually matter. And look at that, they follow the exact same predictable downward curve. This is the proof. Being a better student directly translates to being a safer driver. So what this means is, for pretty much the first time ever, we have really strong evidence that you can make an autonomous driver safer and more reliable just by scaling up its training. More data, more compute. That's it. This is, and I'm not exaggerating, a massive insight for the entire industry. Okay, so we've established that bigger and more data is better for training. But what about performance on the road, in the car itself? Is it possible for a smaller, more efficient model to compete with a giant one if you just let it think a little harder about every decision it makes? And this chart here tells a really interesting story. You can see that if you give a smaller model more processing time, more thinking time, its performance goes up. It can even become competitive with a much bigger model, but only for a while. See that point where the lines cross? Eventually you just hit a wall. The bigger, better trained model is just fundamentally more efficient. It gets to the right answer with less effort. And these images give you a perfect visual for why that is. On the left, with less thinking time, the model is predicting a few possible paths for the other cars. You can see them as those scattered blue dots. But look at the right. When you give it way more time to think, it explores this incredibly rich and diverse set of possibilities. It paints a much more accurate picture of what might happen, which gets it a lot closer to what actually happens. So, after all that, what's the big picture? What does this all mean? Let's wrap things up and look at the key takeaways from this really landmark piece of research. So, here's what we've learned. Number one, improving self-driving AI isn't guesswork anymore. It's a predictable science, just like with LLMs. Two, data is absolute king. These models need way more experience than language models do. Three, and this is so important, the grades we give them in training are a really good indicator of how safe they'll be on the road. And finally, number four, at the end of the day, scaling up, bigger models, more data, is the most powerful tool we have for making progress. And that leaves us with one last really fascinating question to think about. If a car's performance gets better in a predictable way with more data, then what's really going to bring us the future of self-driving? Is it some clever new algorithm that nobody's thought of yet? Or is it just a race to collect the most miles?